Hi, I'm following along with Paul McWhorter's Raspberry Pi Pico W lessons. In lesson 36, he's talking about controlling a servo with MicroPython. Um, I have done my last video was showing how I did create a module for doing the servo and doing the math and everything. But we'll talk about what Paul's got going on here. He shows us all the math for doing this and work through all why we need a pulse length that we do and how to calculate the pulse length and everything. And he comes up with some hard-coded numbers here, and then he takes them and he just decides that he wants to have his these hard-coded numbers in his slope as well as 0 to 180 in his slope as for numbers in it. And then he goes through the slope equation and simplifies it down and ends up with this this equation here to get his right value for a certain angle that he wants. It spits out your PWM value that you'll need to get the angle that you want on your servo. Yeah, most times you're good with servos going from 0 to 180 or whatever, but as I explained in my module video, sometimes it's better to do it a different way, not having the 0 to 180. And our homework for this one was actually a good example of that, is that he wanted a pot, hook up a pot to one of the analog pins and potentiometer to one of the analog pins, and uh, um, use that to control the servo. So if you have all this work to do this, or you could, you know, you could rework all the work. But if you, instead of hard coding these numbers in this equation here, you could use variables, and that's how I did it in my module. So it's going to make it really easy to I don't have to rework the whole equation. I'm just plopping in different values for what's here, and that's what it is. Another thing that I don't think Paul has ever covered, I've watched most of his videos on slope, and I think, at least in my memory, all his X1s have been 0. So he doesn't have to worry about the X1 down here in his equation. But sometimes, what if you wanted to go, instead of from 0 to 180, what if you wanted to go from 90 to 180 or something like that? And this wasn't a 0 here. So the way you do that for this equation is whatever your number you're putting in here for your angle or your position or whatever, you have to take that and subtract the x1 from it. So it'd be, in this case, it'd be angle minus x1, and you would have to put that in parentheses. And then you're multiplying it by the slope, and then you would add the y1 back into it. So you'd have to use some parentheses in his thing here, angle minus x1, multiply it by that, and then add that back in, and that will give you your value. So let me bring up my Thorny. And I don't know if I can get both of these on the screen at once. Let's see. Yeah, I think we can get that. So anyhow, if you can go back and watch if you want to review of what this servo module does, but we'll talk about the slope. So Paul does his slope up here, and he ends up with a slope of that up here. And I calculate the slope, and my inputs for initializing the servo already give you the 4 values that you need to figure your slope. So I got that up there. And then, like I said, if you're making this a module and you're going to let the min value of the min angle or whatever you want to call it of your servo to not have to be a 0. You can make it a you know, a 50 to 100, or you can make it minus 90 to plus 90, or you can make it minus 1 to plus 1. I showed that in the video. Anyhow, this x1 would become non-zero at that point, and you have to account for it. So down here, when you get this equation here where you do all the math to do that, this is your y1 that he's equated out. So I got my y1 is right here. And then slope here. I just put the angle on the other side that multiplied. So the angle times slope is what I got. But like I said, you got to do the angle, I call it position, and you got to minus the x1 out of it. So my x1 is my min position of the servo. So you get this calculation here times the slope. So you do a subtraction here in parentheses, that's the first operation. Then you multiply that by the slope. And then the final operation would be the addition here to add in the y1 value. So like I said, I don't think I've ever seen Paul do it where this has been non-zero, but that's how you would have to do it, and that's the equation you get in. And like I said, I'm putting in variables for this that you know, that you can, as you, no matter if you make one servo or many servos, your servos could have, each servo could have its own minimum and maximum position here. You could have, like I say, you can have the default is going to be 0 to 180, but you can override that and make it minus 90 to plus 90, or what I'm going to do for the potentiometer, since your potentiometer readings are between 0 and 65,535, I'm going to make my max position 65,535 when I create my servo, and then I don't have to do any math in the I don't have to do any math in the part of the program. It's going to be a direct correlation. So that's what we're going to do on that. So anyhow, that's that part of it. So let me move things around here a little bit. There we go. So we can go back to this now. So Paul's original thing is to create a potentiometer to do this, and we got this like I said, because I talked about in the last video that if you're just using a servo, you don't need to import machine because it's part of the servo module. But we're doing a potentiometer, so we had to import pin and ADC from that. And we also need sleep because we're using sleep in our thing there. So like I said, my servo, normally you just say servo and all you need is a pin number, but you can also override the other values in there. So the min position value is 0 by default, and that's good for this, but I need to change my max from 180 to this number. So now my servo range is going to be, my input into my position is going to be 0 to 65,535, which is exactly what we're going to get from our pot value when we read our pot. So that makes it super simple. All we do that, and it's like Paul said, since we're actually having when we do our 50 hertz frequency on our pot, we are actually only updating that every 20 milliseconds. It's only changing every 20 milliseconds. So you need at least 20 milliseconds in here so that you're at least not changing your value any more than 20 milliseconds. Or like Paul said, you're going to go and get jitter or whatever. So we can go ahead and get this to run, make this bigger. I didn't bring out my other camera today. I'm just going to slop down the laptop thing. Now, guys, set up. You'll see 2 servos, but we're actually just going to, with this program, we're only controlling this servo. And of course, we got the potentiometer here. So I'm going to go ahead and hit run. All right, so you saw the servo move, and now I'm going to hold this and turn the knob. You see we're moving around nice and steady. So there we go. That solved the initial part of the homework, but you know me, I don't stop with just the initial part. I like to see how far I can take it. And so I've actually thought about, okay, so we got this sleep in here. It's only 20 milliseconds, but the microcontroller, even this, a microcontroller can do a lot of work in 20 milliseconds. So sleeping isn't necessarily a great thing. Plus, like I said, we got the opportunity with our servo module that we can make more servos. But when you're controlling them and you want to time, when they move and everything, you're not going to be able to do it with just the, with a sleep, because you're going to run out of, your timing's not going to be right. So I decided to, take it to the blink without delay type thing that I've talked about in previous videos. So where you do this times tick differential, and you read it and you wait for the interval to go before you do your if statement here, before the if becomes true. So like I said, we have this read interval here, so you're going to have the read interval, and like I say, it's because you're in milliseconds. You got you're going to be in milliseconds as your timing. So like I said, we wanted to do this every 0.02 seconds, which is 20 milliseconds. That's what we got. That is our interval. And you got to initialize this previous read value, and you just do it 0. And that means it's going to run the first time through. So let's just say you get this. So you got this ticks differential is like it's subtraction, but it takes care of the rollover that might happen in this. So this is the same as saying if the current milliseconds, this time dot ticks milliseconds is like the current milliseconds, is if you take that and subtract the previous milliseconds from it. So let's just say if this is 1,000, when it takes a second, it won't take a second to get here the first time. But say if this is 1,000 minus 0, then that's going to be greater than the 20 milliseconds that we have here. So therefore, your if statement's true. So then you're going to do this. And so that's when you go out and we do read our pot value, and then we set the servo. And then the thing you have to do when you do this is you have to update the previous read value here. Our interval stays the same in this case, but the previous read. So like I say, if this was 1,000 or something, and ticks milliseconds, if this is going to be 1,000 here, so it's going to go right back through it. So this might only be 1,001 ticks milliseconds. So 1,001 minus 1,000 isn't going to be 20. So this is going to go through here quite a few times before it gets back to when this is 20, and then it'll do it all over again. So it's taking care of the sleeping, but the thing is that each time that this doesn't pass, it's going to drop through it, and you can do other things down here. So that's the reason we want to do that. So on the last video, I showed this section of code where you're taking a servo and you're putting it in a position, and then you're sleeping, and then you're putting it in another position, sleeping, put in another position, sleeping. So I said, well, how would we handle this? Because we got, several positions that you want to go to, and then you want to go back to the beginning. So you got these positions. So you could actually, what I decided to do is, okay, this is a list. So we can make a list of these positions and we can work through that. So like I said, this is where we were on this one. No, this one, where we're using our timing thing instead of using sleep. So we're not using sleep. So you can't use sleep on any of them at this point. So we got this second section down here, but it's a little bit different. So here's our one that we need for here. We need just our read interval, and we need our previous read, and we still have this, and I call it previous servo 2, and we're going to make that 0. And we got our interval is we were moving every 2 seconds or 2000 milliseconds. But we want to work through our positions. And if you notice, I set up that servo 2 as being -1 is the min position and a max position of 1. So 0 would be the 90-degree point in there. So what I did is I went from, in my list, I went from -1 to -0.5 to 0 to +0.5 to 1. And so we want to keep track of where we are in this list. So I have a S2 index, and we'll start with the 0 index, and we'll do that. And as we go through our moves, we'll have to increment our index. So we'll do that. So this is all going to do the same, and it's going to look for our reading every 20 milliseconds, and it'll update the position of servo 1 based on whatever the pot position is. So this should still be very responsive. And then this is also a timing, and like I said, this is a 2-second interval here, so it's going to drop out of here very often before it does anything. There'll be thousands, hundreds, probably 1,000. I think if you do the math from 20 milliseconds to 2 seconds, it'd be 1,000 times it's going to do this one before this one will go. But they're going to check each other all the way through, and they only do the if part if if your time's up. So we still have the same thing there, and we're setting the servo, but instead of setting the position, we're setting the index of that position. So S2 has, when it starts out, it's going to have the 0 position. So S2 0, which is the -1 up here. And then it's going to do that. But then we're going to increment our index. And we're going to say that the new index is old index +1. But we're also doing a modulo operation here based on the length of this list up here. And what that does is the modulo, when it gets to the end of the list, it's going to go back to 0 by doing this length of that. So it's going to keep increasing, and when it gets to 3, it's going to be good. But then because you got 0, 1, 2, 0, 1, 2, 3, 4. So this is, say if our index is 4 and we add 1 to it, then it becomes 5. But our length of our list is 5. 1, 2, 3, 4, 5. So this modulo is going to say, it does the remainder. The modulo gives you your remainder of your division. So if you have this result of this is going to be 5 divided by 5, remainder 0. So what it's going to do is give our remainder here. So all the other ones, so if this is end up being 4, it's going to be 0 times in remainder 4. So this is going to be 4 when it does this math. But when it gets up to the 5, then it's going to automatically increase. So it's just a way of doing like a revolving counter type thing. And I picked that up in Arduino, but it follows through on any programming language where you can use this. It has a modulo where you can do that. And then, of course, like I said, same way up here, you have to, each time it does it, you got to update the previous number so that we have a new previous number to look for on that thing. So we can show this working. So this is going to go from 90 or from 0 degrees to 45 to 90 to whatever the next one is, 135 to 180 in degrees, but you don't have to have degrees. You can have whatever numbers you want in there. Let's see if I can get this going. Make it big again. I'm going to run this thing before we get started so I can actually see what's going on here. Oh, I didn't never finish the other one. I got Control C. Okay. And we're going to run it. All right. So you can see that the second servo is doing its thing moving, but we'll go ahead and this one is still very responsive. They're all doing their thing. So I thought about that and I said, well, that's a lot to take in. But maybe there's one more thing we wanted to do. So this, as you saw, that the interval was always 2 seconds on here. So like if you were wanting to do like animatronics or something like that, or an art display, you might not want it to go the interval at the same time. Maybe you wanted to adjust the position, but you wanted to adjust the position. Maybe one time you wanted to move it, you wanted to wait a second. Maybe another time you wanted to wait 2 seconds. Maybe another time you wanted to wait 3 seconds or whatever. So how would we go from where we have now to that? And what I decided was that instead of having just a list with values in it, we could have a list with tuples with the delay as well as the position in it. So our delay plus our position. So we'll go to the next one, and that's what I'm going to show. Is now we have a list of tuples instead of a list of just single numbers. We got a list of tuples, and each tuple is the delay value and the move to it. So it's going to, so when we're on this, it's going to delay for this amount of time, and then it's going to move to that, is, you know, set the servo to that, and it's going to go there. Then you're going to increase the index, and you're going to wait this length of time, and then you're going to move the servo to there in the same way all the way through. So you can, like I said, it's interval and position is what's in there. So that's kind of cool that we can do that. And almost everything else stayed the same. The only thing is now we got to address our S2 with a 2 brackets instead of the 1 like we did before. So like I said, this is all the same, and this same. So before we just had S2 and then we had an index, but now we got to decide which part of the tuple do we want to do. So we actually didn't have this up here. This was our interval before. Remember, that was a set interval that we had at 2 seconds. But now we're getting our interval out of our list of tuples. And so now we can get, we have to address it so it's S2, and it's the index we're on, and in the tuple it's the zero element in that. So then it's this 2000. So when we do that, then we go down here and we can we're setting it, but this time we're setting the index, but we're setting the second element of the tuple, or which is 1. You got 0 and 1 index of the tuple, and then we got our same, this part's all the same down here, so we can just see that working, and we'll get that going. So let me stop the other one first. It's still going around. All right, we can make it big, and you can see that now we got different timing on our when we run this. So each one's got a little bit different timing. And we got to show you, of course, that we're still working good with our, everything's still working good with this. No, I think that's enough. Probably way longer video than I wanted it to be, but anyhow, I just wanted to show what I've been up to this afternoon. Thanks for watching. Have a good day, everybody.